We have a new type of example. We have not done this type of challenges before, but you can still do it if you have a solid understanding of what we have discussed so far. Okay, a machine cost $30,000. Now, oil and maintenance, $2,000 payment, P. Savings, $10,000 per year. So you see, it has many elements. Salvage value after 5 years is $7,000. It is asking you for calculating the rate of return. What is the rate of return for this investment? That you buy a machine for $30,000. It costs you for maintenance and oil $2,000 per year. In addition to that $30,000 at the beginning, it generates for you income or save you $10,000, and you can sell the car after the machine after 5 years for $7,000, less than 30% of the original value. What is the rate of return for this investment? Yes, you can use Excel sheet, but at the first step, first draw the cash flow diagram and play with that before I show you the answer shortly. Stop the video. In this example, it is asking you for rate. And never miss this metadata Excel provides you. Here it says returns the interest rate per period of a loan or an investment. For example, 6%. It's very helpful, especially when you are new in this field. Make sure you read all this explanation that is provided to you by Excel. In our example that now we are working on, the number of periods are 5. What is PMT? Here we have 2 PMT. According to the example, 1 PMT is the annual cost of oil and maintenance that was mentioned in the question, and that's the reason I have put minus 2,000. And another one is 10,000 saving annually. So it would be plus 10,000. Do we have anything else? No. Okay, what about PV, present value? Yes, we are paying $30,000 at the beginning of the cash flow timeline. So here for PV, pay attention to these bold parts in the video, in the guide. So $30,000 and FV, future value, the salvage value, at the end you are going to get $7,000. And that's it. When you have this and you click, you get that it tells you this investment return is 15.4%. So what does it mean? It means that if you already have $30,000 in your bank account, that they are paying you 4% annually, absolutely it makes sense to withdraw all that money and invest it in the thing. But remember, we are not still talking about risk, because we know that when you have your money invested in a saving account in a bank, especially when it is FDIC, means federally insured, at least you can always have that in your mind. always can get the principal money, the main money. It is always saved. When it is especially FDIC. But with this investment, again, we are not talking about risk now. But I'm telling you, when I'm in my conclusion, say that if you have money in your bank, go and withdraw it and invest in this, because it says that 15.4, but in condition that there is no risk. Because sometimes, even with high returns of 15.4% in comparison to 5 or 4%, still it is not attractive enough, because it imposes a big risk on you. But in the situation of equal risk, it says that, wow, this rate of return is way more attractive than the 4 or 5. And again, just see the opportunity that now you have with knowing all these numbers. Just imagine before you know all the things. I'm not saying that you are learning it in this class. I'm just before knowing these things, or the people who don't know this type of things, when they are offered such an opportunity, if they are intuitive investors after many years of investing, yes, they can come up with some conclusion. But when you are just new in this field, now the numbers come to your help, and you are acting like a data analyzer. Here you see another way of doing this challenge with PV function, but the way we did it, I believe, was the easiest way to do, and you don't need to go through all the things. But both are equivalent, because here you see it is saying that all the present value should be equivalent, so the result would be 0. Here we have minus 30,000, because it is the amount of investment now, and after it gets the present value of this one, and then it gets the present value of this one, and then it tries to find what interest rate can make it equal. So it's to start playing. But I told you, here we are focusing on the concepts, not math or anything like that. So at this point, I prefer you learn it the way I just showed you and get the answer, because any approach you take, the answer should be the same. But make sure you also have understanding of this logic. In continuation of the second method that I just showed you, that instead of directly get the answer from the software, you can create your own style. Here you see they try to calculate the present value. As you can see, it puts the present value of all these payments, and it tries it for 15% and 18%. What happens for 15%? They get the present value is a positive number. What happens with 18%? The present value is a negative number. So after that, they go for example, something is between. They go for 16%, because they notice that it is closer to positive when it is 15. When for it is 15, it is closer to 0 in comparison to this one. So they go with 6%, and after that they go with 15 point. Like that they do it. But at this point, try to do it the way I explain it to you. But again, make sure you understand the logic here. We never leave anything not understood. Do this example any way you like. The firm invests $75,000 to save $9,000 per year in energy costs for 15 years. Now, don't take it for granted. It's a question that many companies deal with every day. should they buy and make that hefty investment in solar energy? Very easily. Now you can do that type of thing. Based on the data that you gather, the cost and all those things, you can come up if it is worth it or not. And also you can put analysis on that if now it is not worth it, under what condition it is worth it, and like that. So now you want to see that if in this case that we have, the firm invests $75,000 to save $9,000 a year in energy cost for 15 years. Is it worth it or not? But the point is that here we don't have interest rate, because only with interest rate we can say if it is worth it or not. So here it is asking you, what is the project's rate of return? In fact, you are going to calculate the rate of return that make those two cases equal. And of course, under that rate of return, we can decide if we want to go for that investment or not. Stop the video and calculate the rate of return. We are going to calculate the rate of return in two ways that we have learned. The first one is that straight one, easy one. You put rate and the number of periods is 15. The PMT, the payments, the savings you receive for 15 years is $9,000 and the p-value is 75,000, the one that you pay out of your pocket at the beginning of the investment. So you want to see what is the rate of return for this investment, and okay, 8.44 is the answer. Also, I want to show you how to do it with the other way so you don't overcomplicate it about the other one. Here I have put the trial and error rate of return that we are going to work on here. Here it says if the rate of return, if the interest rate is 0, the present value is $60,000. Of course, we don't want this value, we want it to be 0. So what we are going to do, we are going to calculate the present value of everything, the same as we discussed it in the previous example. So we are going to calculate the present value of any cash flow that we have in the diagram, in the cash flow diagram, and we make sure the summation of all of them are equal to 0. We want to make sure the upward and downward have equal present value. Okay, one of the things that we have is $75,000 now, so we put minus 75,000 here, and also we have the 15 payments of $9,000, and what is the rate of return? Here is 0. I have put, but we are going to play with that. So present value of the payment plus the present value of the investment at the beginning must be 0. So now here we have 0, it is that one. So I'm going to put 10. So remember, for 0, it was a positive number. Now for 10, it is negative. So we are sure that rate of return is between 0 and 10. And remember, 10 is negative. I'm going to put 5. 5 is positive. So it should be something between 5 and 10. I'm going to put 7.5. Still positive. So it should be something between 7.5 and 10. So I'm going to put something in between 8.75. It is negative. So it should be something between 8.75 and 7.5. I'm going to put something in between. So I'm going to put 8. 8 is positive.